jitu penuh bermisi guru ayu mencapai misi yang satu permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam Sejahtera dan good afternoon everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of EDDET Malaysia and Club Guru Malaysia. Bermula PERCUMA, selamanya PERCUMA. So I am Mr.Peh. Currently I am teaching at College Tingkatan 6 Tun Fatimah, Melaka. I am the teacher on duty for this week. So please subscribe my channel and like and share the link for class today to your friends so that more of your friends will be able to get the benefits from my lesson. Okay, so without further ado, so let us start our class today. So again, today we are going to learn the topic of physics in Form 4 in this 1 hour. So we are going to continue the chapter 6, line optic. And last week, you actually already together with Cikgu Hasnitah in subtopic of 6.3. So today, we are going to continue our subtopic of chapter 6, which is 6.4, thin lens formula. So in this subtopic, there are 2 learning standards you are going to go through today. So for learning standard 1 is to investigate the relationship between the object distance and the image distance V for a convex lens. And secondly, to determine the focal length of the thin lens using lens formula. So that means in learning standard 1, you are going to understand one of the experiment, which is experiment 6.3. You may find the detail in your textbook at the page 259 to 260. Okay, so that means in this learning standard 1, we are going to focus in the experiment, which you also able to relate this experiment to the paper 3. Okay, so this is the inference for the experiment where you actually can get through your textbook. Okay, so the inference will be the image distance is influenced by the object distance. So that means here the image distance is actually our responding variable. And then our object distance will be our manipulated variable. Okay, then the hypothesis will be when the object distance decreases, the image distance will be increases. So you can see from this figure, so the U will be the object distance. So the object here will be the triangle. Hole you may see on the cardboard to the convex lens. Okay, and then the image distance V will be here. So there will be an image form on the white screen. So you want to see the distance here. Okay, and then the aim of the experiment is to investigate the relationship between the object distance and the image distance for a convex lens. So here you want to see the relationship between the V and also the U. So here will be U and V. Then this is the highlighted part, okay, in our lesson today. So because in your textbook, you are going to draw the graph, which is 1 over V against the 1 over U. Okay, so here we'll discuss another graph which is related to this experiment, where will be the graph V against U. Okay, then the second M is to determine the focal length of the thin lens using lens formula. So it'll be this 1 over F equal to 1 over U plus 1 over V. Okay, so this is the formula, lens formula, and you'll be plot the graph 1 over U, 1 over V against 1 over U. So from the graph, you can determine the focal length, which is similar to the discussion in your textbook. Okay, and then the third experiment, the third aim will be to determine the focal length of the thin lens without using lens formula. So this is also another highlighted part for discussion in Learning Center 1. Okay, so I'm using the graph V against U to get the focal length. Okay, focal length for the lens without using the formula. Okay, so before we go to the detail, okay, so you may actually, okay, so download my worksheet for today's lesson. Okay, so with the link I'm showing you here. Okay, so please download by using your MOE email. Okay, so this will be the worksheet for today's lesson. Okay, so let us continue. Okay, so the variable for the experiment will be MV. Here will be the object distance, U, as I mentioned just now already. Okay, and then the corresponding variable here will be the image distance, V. So you will be measure the V by using a meter rule. Okay, and then the constant variable here will be the focal length of the lens. So that means you'll be using the same convex lens for your experiment. Okay, then the next here will be the apparatus listed. Okay, so this one will be convex lens. You can see it here. White screen will be here. Lens holder will be this. Meter rule. Bulb. Power supply. So it will be connected to the bulb. Okay, and then cardboard with the small triangular shaped hole will be this. Okay, and then the wooden block will be this. Okay, so basically the procedure will be this. Okay, so set out the apparatus as shown in the figure. So it will be this. You have to draw. Okay, so this is a procedure where you actually can apply at your paper 3. So you can draw your apparatus, and then the first mark will be given with this sentence together with your arrangement. Okay, so set out the apparatus as shown in diagram. Okay, will be like this shortly also. Okay, and then the next here, the object distance is set out at 20 cm, and the bulb is switched on. So you may see the next, the screen is adjusted to obtain the shape, to obtain a sharp image, and image distance is measured using the ruler and recorded. Okay, and then step 2 and 3 will be repeated with the object distance U equal to 25, 30, 35, and 40. Okay, so let me show you the video. Okay, so I think I can show you like this. Okay, so you can see initially, okay, so you need to on switch on your bulb, okay, so that the light will be passed through the lens, okay, with the distance you set already. So where here will be the U. Okay, then you need to adjust your widescreen. Okay, adjust your widescreen until the image form on the widescreen become sharp. Okay, so after that, you need to measure your V. Okay, so you can look at the video again. Okay, so it will be adjust until the image is sharp, and then you may measure your V. Okay, understand? Huh? So repeat the same step for the U with 25.0. Okay, and then 30, 35, and 40. So for the each U, you need to arrange your widescreen until the image form on the widescreen becomes sharp. Then you measure your V. Okay, so here we have the Cikgu Hasnitah. Okay, so thank you, Cikgu Hasnitah, for support me here. Okay, so the next will be tabulation. Okay, so this is the result and the table you may actually find or get from your textbook, and I also already put in my worksheet today. Okay, so again, you may get my worksheet with the link with MOE email. Okay, so basically, the first reading I get will be 60. Okay, so my reading will be when my U equal to 20.0. So I adjust the widescreen until I get the sharp image form on the widescreen, and I measure the distance V. So here I get 60, and then the next I change the value of U here. So the distance between the cardboard and the lens will be 25. And again, I adjust the widescreen until the sharp image will be formed. Okay, so here I get the value will be 37.5. Okay, then when U equal to 30, then I get the value will be 30.0 and also the others value. Okay, so if according to the textbook, you will be plot the graph 1 over V against 1 over U. Okay, so you need to find out the value. So with 1 over 20, so you get 0.050. Okay, then 1 over 25, you get 0.040 and also the others lah. Then for the reading of 1 over V, so you use 1 over 60. So you will get 0.017 with 1 over 37.5. So you get 0.027. Okay, so and also others lah. Okay, so this is how you get your primary reading and also the secondary reading based on the discussion in the textbook. Okay, so now we go to analysis. Okay, so according to what I mentioned just now, okay, so this is the first end of the experiment where we actually want to investigate the relationship between the U and the V for the convex lens. However, in your textbook, you are just requested to draw the graph 1 over V against 1 over U. Okay, so here we are going to draw the graph V against U to investigate the relationship between the U and V here. Okay, so this is a reading where I already measure in the experiment. Okay. Okay, so because we just need to plot V against U, so we just need to use the value of U and V. Okay, so here will be the first reading. I get 20 U, and then I get 60 V. Okay, so this will be our first reading. Okay, and then second reading will be 25 together with 27.5. Okay, so your as this must be consist of the parameter. Here will be V and U, and then must be including the unit, and then the scale for X and Y as is here must be including the maximum and minimum value. For example, here 20 and 40. So the x-axis here, you can see the maximum reading 40 is included, minimum is together with 20. Okay, so here the reading must be start from 0 and increasing consistently. You may not start your first scale with 20 here. So I say your first 1 unit here represent 20, here will be 40 already. So please avoid this kind of mistake when you are plotting the graph for your compulsory experiment or your paper 3 also. Okay, and then for the V, the maximum value is 60 and 24 is included in the scale already. Okay. Okay, then the next here, you must draw a smooth curved line for these 5 data where I get in my experiment here. Okay, so you can see this will be a curve. Okay, so this graph will be the best graph to showing the relationship between V and U. Okay, so from this graph you can see, okay, so the relationship between the U and V is when the value of U increases, so you can see the value of the V will be decreases. Okay, so the answer for the relationship between U and V will be when the image distance increases. So that means when U increases, so your image distance V will be decreases. Okay, so this is actually the best graph to showing the relationship between V and U. Okay, so you may take note, okay, for the experiment may be asked in your paper 3. Okay, so the next will be the second analysis, where is the graph we're going to discuss exactly same with your textbook. Okay, so it's to determine the focal length F of the thin lens using the lens formula. Okay, so the lens formula will be 1 over F equal to 1 over U plus 1 over V. Okay, so here the question asking you to plot the graph 1 over V against 1 over U. Okay. Okay, so this is the data where we get just now. Okay, so the tabulation is actually discussed already just now, where the data going to collect is same as the data you want to do at the textbook. Okay, so this is the data we get and explained already just now. Okay, so now we focus on the graph. Okay, so against here will be where request by the question 1 over V against 1 over U. Okay, so remember, set your parameter. Okay, parameter with symbol given at the question, and then the unit cm per cm here lah. Okay, for x-axis and y-axis, and then again your scale must be including the maximum and minimum value for your V together with your U also lah. Okay, okay, so the first reading here will be 0.17. Wait, I think the graph 0.1, 0.17 0.05 to 0. Okay, I think I start my value with this point first. Huh? Okay, you can see here the smallest 1 over u will be 0.03. 0.023. So this is a 0.023 with the value 0.042. Okay, so I started with the smallest value of 1 over u. Okay, so it will be this. Okay, and then second and third reading will be, second will be this 0.09 and then 0.38. Oh, okay, and also others. Okay, so you can see this is a 5 point where will be the straight line actually here. Okay, so this will be the straight line you are going to draw for this this side of the graph. Okay. Okay, and then the next question. Okay, so will be related to the graph. Okay, so here, as mentioned, we using the thin lens formula for identify the f here. Okay, so and we plot y, which is 1 over v, against 1 over u will be this. Okay, so here you can see the intercept. Okay, y-intercept will be represented as the 1 over f. So from here, you may identify the focal length for the lens here. Okay, you can see the gradients here is actually -1. -1, and then the c here will be 1 over f. Okay, so that's why we plot the graph 1 over v against 1 over u to identify, to determine the focal length for the lens for the experiment. Okay, so here the first question will be determine the intercept for both axes. So that means you need to find out the axis x, y here, intercept x, and the y intercept here. Okay, so if you zoom in, you can see the reading here is 0.067. And here is also, you can see 567 will be also 0.067. Okay. So these two coordinates will be 0.067 for y-intercept and s-intercept will be 0.067, which is actually meet the requirement for the thin lens formula, where the m here is actually -1. You can see here 0.067 divide 0.067, we get 1. And the graph here showing decreases. So this will be -1. Okay, so here the answer here very clear. So the both intercept will be 0.067. Okay, you can see the answer as intercept here will be 0.067, and then y-intercept here will be 0.067 cm. Okay, then the E, determine the gradients of the graph. Okay, so we need to draw triangle, a big enough triangle, which must at least 4 times 4. Okay, then you get this point and this point. So using formula, y1 minus y2 over s1 minus s2 lah. So which will be this? So you'll get the reading, which is about -1, and meet the equation, okay, for thin formula, for thin lens formula lah. Okay, and then the next here, okay, so using lens formula and the graph plotted, determine the focal length. Okay, focal length of the length in this experiment. So from discussion, okay, so we know already the y-intercept, okay, y-intercept will be represented as 1 over f. Okay, c equal to 1 over f. So the f will be equal to 1 over c. Okay, so our c here is 0.067. So you'll get the focal length will be about 14.93. So it will be approximate to 15 cm. Okay, so this is how we determine the focal length of the length in experiment by using the graph 1 over v against 1 over u, which is using the thin length formula. Okay, so for the third analysis here will be to determine the focal length of the lens without using lens formula. Okay, so here is actually another analysis where is by using the same data, but I using the graph v against u, which is the first graph I discussed just now. Okay, so here will be the graph where I already plot and discussed in the first M. Okay, so from here you are actually can also determine the focal length. Okay, but you need to apply the theory you learn at the subtopic 6.3. Okay, so here you can see when u equal to 2f will be here. So your v will be also 2f. Okay, so where your image form is actually real, inverted, and same size. Okay, so this is already learned at the subtopic 6.3. Okay, so how we relate the theory you learned at 6.3 to this graph. Okay, so here again, just like I mentioned to you, u will be equal to v when the u is equal to 2f. So when u equal to 2f, your u will be equal to v. So that means here you can plot another line, which is u equal to v here. So you can see when your u is 10, your v will be 10. Same also for the second reading. 20 for u, 20 for v. And also others 2 points here. So here you can draw another line, which is v equal to u. So you may see one intersection point at this line, the straight line and the curved line here. So it's actually 30. Okay, so this will be u equal to 30 and equal to 2f. So from here, you may get your f already. Okay, so the f will be u over 2. Because from here, u equal to 2f. So f will be u over 2. Then you substitute the value 30 here, divide 2, you will get 15 cm also. Okay, so this is just a extra discussion for you to relate the experiment to paper 3 actually. Okay, so that means this subtopic 6.3, 6.4, learning standard 1 is a very popular question actually. Okay, may actually ask you in paper 3. Okay, so here is another example of question. Okay, it's a Clone SPM paper 3 question. Okay, so maybe asking you to do the experiment and do the analysis. Okay, so this is a sample question where we also using the value of u and v, and the question asking you different type of graph, and you need to identify or determine the value of the f here. Okay, so this will be the question I designed. Okay, so you may actually apply in your paper 3. Okay, so this experiment is actually happen us in the KSSM since 2021. Okay, the topic of Form 4. in your paper 3. Okay, so this is the idea for you all actually. Okay, so you are required to carry out the experiment to study the relationship between the image distance and the magnification M. Okay, so here, this is a different parts where the question actually requires you to study between the V and magnification. Okay, magnification are using capital M lah. Okay, to avoid the conflict between small m, which is represent the gradients lah here. Okay, so the step will be also the same. Okay, so ask you to set up the apparatus as shown in diagram. Okay, again, the reading I use start with 20 because I already have the reading, which is the data I already explained just now. Okay, started with 20 cm. And then again, you may adjust your widescreen. Okay, you can see will be same as just now. Okay, will be same as just now one. Okay, so firstly, switch on the bulb and then get your first U, which is equal to 20. And then adjust. Okay, adjust your widescreen. Okay, until the triangle. Okay, sharp triangle is formed on the widescreen. And then you may measure your value V here. Okay, so this is actually the same shortcut with just now one. Okay, so here repeat step 2 and 3 here with the U equal to 25. So that means you adjust your lens and the bulb. Here is actually the triangle now. Here is actually the triangle, the cardboard. Okay, the cardboard, which is 25 cm. Adjust the widescreen until the sharp image form on the widescreen. So you measure your V. And then repeat with 30, 35, and 40. Normally it will be 5 and V lah. And you will get 5 RV. Okay, so again, so this is the first question, tabulation. So this is a different tabulation data you are going to measure and calculate. Okay, so by using the equation M equal to V over U, so this is a magnification equation where you already learned at the subtopic 6.3. So it's actually related to 6.4. So, okay, so tabulate your result for all the value U, V, and M here. So the M here is a magnification. Okay, so for each value of U in the space provided. Okay, so here again, I'm using the same U, okay, which is requested by this question also lah. Okay, so started with 20. Okay, so for tabulation, here will be have the 6 tick you need to fulfill. Okay, so the first tick will be you need to stack the quantity physics in your table. Second will be the unit cm. The magnification, there will be no any unit here. Okay, so that means here will be no need to stack any unit. Okay, then the second mark. Okay, so this is the first symbol or parameter, as I mentioned, which is a quantity physics. Then the second will be give the correct unit. Second tick. Okay, then the third and fourth will be primary reading with decimal place based on the sensitivity of the apparatus and consistency. Okay, so what means by this? Okay, so here the sensitivity of the instrument here will be using the meter rule. Okay, so the meter rule, you can give with the 1 decimal place or 2 decimal places. Okay, but the second decimal places must be 0 and 5, cannot be others number. But here we follow the decimal places stated at the procedure already, which is 20.0. So we know here will be only 1 decimal place are going to write. Okay, so example Okay, so this will be 1.0 0, and this will be 4.3. So the length for x and y, you minus, you get 1 decimal place lah. So here will be 3.3 lah, cm, right? Okay, so here will be the where we give the sensitivity of the apparatus. Then secondly, you can see all reading, 5 reading here, there will be same decimal place here, which is only 1. So this is a consistency and sensitivity of apparatus. Okay, so for your U and also the V. Okay, so this is 60, where I already measured just now. I'm using the same set of the data here. Okay, so this will be the others also. You can see here is a consistent decimal place. Okay, and I'm using 1 decimal place lah, which is same as the decimal place stated and the procedure. Okay, and then the N will be the secondary reading. Okay, so here will be also another 2 tick. Okay, so secondary reading with the consistent decimal place. Okay, so for the secondary reading, okay, so here will be magnification. I'm using 60 divide 20, so I get 3.00. So here you can give 2, 3, and 4 also up to the graph needed. Okay. Okay, so the others will be also the same. Here I'm using 37.5 divide 25. Okay, so I get 1.50. And then the others also. So you can see here, I using 2 decimal places. So all the reading, secondary reading here will be with the same decimal place here lah. Okay, so if you fulfill these hop tips I mentioned here, they will be, you will get the full marks. Here will be 5 marks lah. Okay, so just like I mentioned to you, for the secondary reading, you can give up to 2, 3, and 4. Okay, so where able to differentiate all the reading and plot the graph. Okay, so if you fulfill 6 tick here, so you may get full marks lah. Okay, and then B, analyze the data obtained in A by plotting the graph with V against N. Okay, so here will be the different graph with the previous experiment we discussed. Okay, the first one will be V against U, we discussed already. Then the second, we discussed 1 over V against 1 over U to identify, to determine the focal length of the lens of experiment. Okay, so here the question asks you to draw V against N. Okay, so you can see the reading needed will be this, where we actually discussed already in A lah, tabulation. Okay, so this will be the graph. Okay, so first tick, just like I mentioned to you, you need to give the quantity physics or parameter here, which is V for Y axis and M for the X axis. Then second will be units for each axis. So here will be cm, and then the Y axis magnification will be no any unit lah. Okay, then the third, you need to give the uniform skew. Okay, so where the skew must be covered minimum and maximum value. Okay, so the minimum value for V, 24, M, 0.60. Maximum value will be 60 and 3.00. So you can see your graph must be covered all the value, minimum and maximum, and must start with 0 here. And then the skew must be consistent with the multiples of 1, 2, 5, and 10. Okay, so you can see here will be 10. Here 0.5 considered as the multiple 5 here. Okay, so here the smallest division, so that means a very, very small box here. So it will be 10 divide 10 is actually represent 1. Then here also the same. Small box here will be 0.5 divide 10, 0.05 here. Okay, so the next will be size of the graph, as I mentioned, must be greater than 5 times 5. sorry, 4 times 4. Oh, 4 times 5, sorry. So the size of the graph must be 4 times 5. 4 times 4 is the triangle for the gradients. Okay, so it must be greater than 4 times 5. That means actually 4 will be here. 5 will be here. 1, 2, 3, 4, 5. So that means actually half of the graph. Okay, so you must draw at least half of the graph. Then plot all the points correctly for the 5th and 6th tick. Okay, so you can see the first tick will be 3.00 will be here. Then 60 will be here. So this will be my first point. With this second point, 1.5 will be here. Then 37.5 will be about here. Okay, so it'll be here and also the others point. Okay, so from here, you can draw a straight line. So here you can see all the point is very clear, is straight line. So it will be the best fit line, another tick. So this is the requirement for the best line. So you can see the first will be the numbers of point at the above and the below the line you draw must be less than 1, 0 or 1. And then the distance of the line to the point must be less than 0.5 cm. So be here. Okay, so for my graph here, okay, so you can see all the point is actually line on the point, so there will be no any problem. And the y-intercept here is actually 15, right? Okay, so if you fulfill this 7 tick, you may get full marks. Okay, so this is the way how you draw the graph for your paper 3 and get the full marks. Okay, then the next question is from the graph plotted, calculate the gradients m. Show your graph how you determine m. So the m here referring to gradients. So firstly, you have to draw big enough triangle. Just like I mentioned to you, must be at least 4 times 4. 1, 2, 3, 4, 5, 6 already. 1, 2, 3, 4 and a half. So this is a big enough triangle. So you must show on the graph for the first mark. Okay, then second, substitute the point. So here will be 3 and 60. Here will be 0 and 15. Okay, so substitute y1 minus y2 over s1 minus s2. So you will get your answer 15 cm for the gradients. Okay, so here the next question. So what is the physical quantity represented by the gradients actually here? Okay, so it's actually the focal length. Okay, so where we get 15 cm, right? For the experiment 6.3 we explained just now. So I'm using the same data and same length here. Okay, so y, you can see from the length formula, which is 1 over f equal to 1. So multiply all with v, so you get this one. Right? Okay, and then the formula of magnification will be v over u. So you can see v over u here will be actually m. So it's related to the graph we draw today. And then v over v will become 1. So you get v over f equal to 1, m plus 1. You rearrange again. So you may see v equal to fm plus f. Okay, so if you compare with 1 equal to y equal to ms plus c. Okay, so the gradients actually is here. Our graph is y. Then here will be the x-axis m. So your gradients is actually represented as focal length of the lens. So here I just want to prove to you. So the physical quantity represented by the gradients here is actually focal length. Besides that, you can see the y-intercept is actually also represent as the focal length. So you can see the answer. So the answer, not answer lah. So the reading at our graph here. Okay, so the focal length is actually, you can see 15. So that means the gradients we get 15. Our y-intercept, you should also get 15 for the graph V against M here. Okay. Okay, so the answer here will be focal length of the lens. Okay, so the next will be from the graph plotted, what is the focal length of the lens used? So as per explanation just now, so the answer here will be, you may get from the gradients, where the answer you get from C, which is 15. Or you may actually using the y-intercept, which is actually also 15. Okay, so answer here very clear is 15 cm. Okay, so step 1 precaution that should be taken to improve the accuracy of the result. Okay, so here for the light experiment, actually you can use this answer. Okay, so the experiment is conducted in dark room so that the light beam can be seen easily. So that means we can identify the sharp image form at the white screen if we conduct our experiment in the dark room. So this is the precaution able to use in any experiment related to the light. Okay, so this is actually the sample question for paper 3 for this learning standard 1 of subtopic 6.4. Okay, so here is another question in 2028. This is the actual question of SPM. Okay, so which is related to this subtopic also lah. Okay, so let us go through the question. Okay, so diagram 15 shows the apparatus used to determine the relationship between the object distance U and the image distance, which is V here. Okay, so here, and the focal length is F. Okay, so the result will be in diagram 16 here. Okay, so what is the value of Q? Q is here. Okay, so actually this one we also discussed already, right? With the formula, thin length formula, 1F equal to 1 over V plus 1 over U. Okay, so we change to the Y equal to MS plus C. Okay, so you will get the C is actually 1 over F lah. So here Q is actually y-intercept. Okay, so here the answer is very clear, will be A. Okay. Okay, so we have already finished our first learning standard. Okay, so we can take a break before we continue our learning standard 2. Okay, so please take a break and then come back again together with me.
Our hearts beat to the city streets. We began to feel the fire. We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine. We wanna chase the night, wanna dance to the light, pull the stars from the sky, just two hearts running wild. Never sleep, never stop, as we shout from the top. We're gonna be two hearts running wild. Now the
Hi, welcome back. Okay, so again, thank you for my best partner here, Cikgu Hasnitah. Okay, always stay with me here. So I hope that more students will be join my class also. Okay, so the learning standard 2, you are going to solve the problem, which is using the length formula. So which is 1 over f equal to 1 over u plus 1 over v. Okay, so this is the learning standard 2, will be the last learning standard for today's lesson. Okay, so this is the relationship between the u, v, and f. Okay, so in the previous subtopic 6.3, you actually using the ray diagram. Okay, so to identify the characteristic of the image formed by the convex lens together with the concave lens here. Okay, so this is the summary. Okay, summary of the characteristic of the image form for both lenses by applying the ray diagram. Okay, so the 6.4, you actually using the formula to identify the characteristic of the image form by also the both lenses. Okay, so here we, again, this is the only one formula we apply at 6.4. And here we have the rule. Okay, so the sign that must be obeyed in the lens formula for convex and concave lens. Okay, so here will be the 4 symbol. So the F represent as the focal length for the lens. U will be the object distance. V will be the image distance. P will be the power of the lens. Okay, so the focal length for the convex lens is actually with the sign positive. So when you see this is a convex lens, so the focal length is actually with sign positive. If you see or question given you the lens is a concave lens, so that means the focal length will be together with negative. So what means by this? So for example, the convex lens given by the question is 15 cm. So they will be positive 15 cm. So if the focal length given by concave lens is 15, so they will be negative 15. So later on, we'll discuss few questions regarding this formula with different lens. Okay, then second will be U. So you can see both is given positive. Okay, you can see from our previous discussion. Okay, so the object we discuss come from the left side. Here will be left side. Definitely your object is actually able to come from the right side. But here you can see all we discuss from left side together with the convex and concave lens lah. So all is from the left. So the left side here, we showing the position as positive. So you can see both U is positive. Okay, then for the image form, for example, V here. So for the convex lens, so the position for the image will be different. Okay, when the U is different. So basically you can see for the first, when the U from infinity, your image is at the right side. Then the second case, when your U is greater than 2f. So the image form is also at the right side. So when you can see for different cases here, when all the image at the right side, actually is first 4 here lah. 1, 2, 3, 4. Where the image will be rear inverted, you see. Rear inverted, rear inverted, rear inverted. No matter the size diminished or same size or magnified. So when the position of the image is at the right side, showing real and inverted image, so you can see they will be positive. Real image, so that the V is positive. So that means when you get after the calculation, when you see your V is positive, so there will be real and inverted image. Okay, so when the image become virtual will be at last two here. So where the U equal to F and U less than F, you can see the image is at the left side, which is together with the object. So this will be showing negative in the calculation already. Okay, so you can see for the contact lens, so the object and the image is always at the same position, which is left here. So that means here will be also showing virtual image. Okay, virtual and upright. Okay, you can see virtual will be together with upright. So this will be negative also lah. Okay, then the P, positive or negative will be depends on this formula. Okay, so here the hot tips just now explained to you already. So when V is negative, so the image will be at the same position. Oh, this one is discussed already. Okay, so for P, so the formula will be 1 over F. So you already learned at the previous topic also lah. Okay, so the positive focal length for convex lens must showing positive P. Then the negative F for convex lens, so the P will be definitely negative lah here. Okay, so this is the theory and the sign you must remember. And here will be the discussion. Okay, so this is the question from actual paper 1 in 2012. Okay, so the question will be like this. So diagram 17 shows an object in front of the convex lens. Okay, so here you must identify positive or negative. So again, the question asks you, okay, what is the image distance will be V? What is the V here? So here we are going to apply the formula, one and only formula, and you need to determine the sign, positive or negative here. Okay, so here you can see the U positive lah, always positive, which is 15. And the focal length here is positive because this is a convex lens. Okay, so that means the given value here is 10 and 15. So you substitute in the formula, rearrange, you'll get 30 cm. So answer is very clear, it's D. Okay, it's quite easy for this past year question. Okay, so this will be the question might be asked you at calculation paper 2. 5 marks question for B and C, and also the section A also might involving some of the calculation question. Okay, so this is an example. Okay, so an object is placed 25 cm from concave lens. So you can see concave lens. The focal is 15 cm. So as I mentioned just now, when this is a concave lens, so the focal length will be negative. Then the object distance is always positive. So the question asking you to calculate image distance, which is V, and then the magnification, and then state the characteristic of the image. Okay, so again, determine the sign, positive or negative for different case here, and substitute to the formula. Okay, so here, U is positive 25, concave lens negative 15. Substitute to the formula 1 over F, 1 over U, plus 1 over V. Rearrange, you'll get your answer is negative 8 over 75 for 1 over V. So the V will be rearranged, the position. So you'll get negative 9.375. So as I mentioned just now, for negative V, so the image will be virtual together with upright. Okay. Then second here, we need to calculate the magnification. We apply formula V over U, and the M must be always positive. If you get negative, you just cancel out the negative value here. Okay, so here you can see the value of V, we get negative 9 0.375 will become positive lah, because the n multiplication cannot be negative. This is a logical thinking now. Okay, so over the u given by question, which is 25. So you get 0.38. So you see the multiplication less than 1. So that means here will be diminished, becomes smaller, the image. Okay, so B identified the characteristic. As I mentioned, when the V you get negative, image form will be vertical and upright. And then the M, which is less than 1, 0.38. So this will be diminished. So the characteristic for the image form for this question will be vertical, upright, and diminished. Okay, and then the next example question will be regarding convex lens. Okay, so here an object is placed 15 cm in front of convex lens with focal length of 10 cm. So again, calculate the image distance, magnification, and then state the characteristic. Okay, so here the tips here will be again determine the sign and then substitute in the question, in the formula. Okay, so here u will be 15, always positive, and then convex lens is used, so the focal length will be 10 cm, positive. So substitute the given value to the formula given. Okay, so you get 30 lah. Okay, so you substitute, rearrange, you get 30. This is positive value. So the magnification, again, will be using formula V over U and will be always positive lah. Okay, then here the V we get is 30. U given by question is 15. So you get the magnification is 2, which is greater than 1. So this will be magnified. So positive V will be real and inverted image. And then the n greater than 1, so this will be magnified. So the characteristic of the image form will be real, inverted, magnified. Okay. Okay, so here we go to our last question, question number 5. Okay, so a light source is placed on the left side of the lens with focal length 12. The image form is 6 times bigger or magnified 6 times on the right side of the lens. So what is the type of the image? Okay, so as we learned already, so this is a magnification. And the image is formed at the right side. This will be only able to form by convex lens, because the convex lens will be only able to form vertical and diminished image. Okay, so here the hot tips. The image form is opposite the lens. So this is a real image, which is only able to form by the convex lens, and the position of U must be greater than F here. Okay, but here is magnified. That means will be greater than 2F. Okay. Okay, so we are sure that the type of the lens used here will be convex lens. Okay, then here, what is the object distance? Okay, so this one you need to identify the U. So here the question given us 2 hints here will be focal length. And here we know already this is a convex lens. So here will be positive 12 cm for the F, because of the convex lens. And then here magnification is 6. Okay, so that means here V will be equal to 6U lah. So this is the given information by the question. Okay, so again we apply the one and only formula in this subtopic. Okay, 1 over F. F will be 12. And then V will be equal to 6U. Okay, because the M equal to V over U. So we get M is equal to 6. So 6 equal to V over U. So that means V equal to 6U lah. Will be here. And then when you get V equal to 6U, you substitute your V as U. So we left one unknown, which is asked by the question. So you rearrange, you get your U is equal to 14 cm. Okay, so this is the problem solving question you are going to see, okay, in paper 1 or paper 2 for calculation part. Okay, so that's all for my sharing regarding this subtopic. Okay, so please subscribe my channel to show your support to me, and like and share the link of the class so that more of the students or your friends able to get the benefits from my discussion today. Okay, and then don't forget to follow the next physics classes, which is actually here on the every Friday, 6:30 p.m. by the Form 5 team. Okay, so for the this week is presented by Cikgu Izyan. Okay, so it's actually the discussion for SPM question. Okay, so if I say you miss out the class, you may go to the Cikgu Izyan channel to watch again the discussion. Okay, and then remember also continue to support our Form 4 Physics class, which is here on every Sunday, 3:30 p.m. And next week will be continue by the Cikgu Hasnitah with the subtopic of 6.5. Okay, so that's all for me. Okay, and continue to support us and see you again. Bye-bye.